If you can hear me, can you type 1 in the chat? Okay, perfect. Right, good to see everyone. So we'll just wait for a few minutes for everyone to join, and then we'll start. Okay. While we're at it, how many problems have you managed to do from the physics assignment? If you haven't started, just type 0. How many problems? Just type a number. I'm interested in to know. Okay, got an 8, a 5. Very nice. Okay. Right, another 8. Okay, not bad, not bad. Any particular problem you're stuck on? Don't give the number. Just tell me which. Oh, okay. You can say problem such and such, and I have it open. Problem with problem 2, so for example. Isaac, is that 8? Are you saying that problem 8 is difficult? Okay. Right. Hello. Hello. Very well. Thank you. Problem 8. Well, you can try drawing it out. That's an easy way to figure it out. Problem 10. Oh yes, problem 10 is quite complicated. Try multiplying the vectors using the scalar product, and you will need to use the formula for the cosine of the angle between. That's for problem 10. Because the cosine of the angle between the two vectors is their dot product divided by the product of their moduli. So that's something to consider. Anything else? Which problems you've had? Problem with problem. I can give you hints. Right, so how many people? 19. Yeah, I was hoping for more. Okay, get some more people. 1A. We're talking about physics. Let's talk about physics today. We'll speak about maths next week. Problem 3, physics. Problem 3. Let's have a look. What is problem 3? Problem 3, just you need to write the vectors in column form. For the physics, when the question wants a direction, should you put it in terms of a direction or something as a bearing? Anything, as long as it is clear, as long as there's only one way to understand it. For example, you can say 38 degrees north of east. Yeah, that means go from east, go 38 degrees to the north. That's very easy to understand. You can give a bearing, or you can say 28 degrees to the vertical, yeah, or 62 degrees to the horizontal. Just make sure there's no ambiguity in like to the 20 degrees to the vertical can be this way or this way. If it matters, I would specify like to 20 degrees from the vertical towards the right. Yeah, but in most cases, 28 degrees to the vertical is clear enough. Okay. Right. So 30 people. Okay, I think we can start. So welcome everyone. This is the first webinar for COMPOS. The webinar is being recorded, so if you can participate, you can ask me questions, especially if there's not too many of you, only 30 people today. If you have any questions about the program, so the program runs for the whole academic year. We plan to give you 12 assignments overall, and the first assignment is also the entrance test. So last year we accepted everyone who got 50% on average for maths and physics. So basically, if a person scored 40 on physics and 60 on maths, they got accepted. 50 physics, 50 maths, they got accepted. Okay. We don't know what's going to be this year, but this is just that's like just for you to understand. Basically, we will have a well, I can say that we won't. If you scored less than 35% on any of the assignments, we'll probably won't be able to let you in. Yeah, just because it's going to be hard to keep up with the program. But anything above that, yes. So depends on how many people we get, how many people submit their work. We try to accommodate all candidates who can cope with the tasks. They're not easy, as you can see. I will be going through very similar problems. So today I've taken 8 very similar problems, and I'm going to go through them, and so that you understand understand the logic behind behind working with vectors today. Oh yes, I haven't introduced myself. My name is Vlad Chernov, and I am the academic coordinator for COMPOS. I write the assignments for you. So I am the author of most of the physics assignments and some of the maths assignments. And well, basically, if you'll see my name on most of the, actually all of the assignments, because if I'm not the main author, I'm a co-author. Right. So without any further ado, any questions, any burning questions before we start? Okay, right. So I will share my screen. We'll share my screen, and I have prepared some questions for you, which I will go through today. If you cannot see my screen, write something in the chat. If you can see my screen, just don't do anything. Okay. Right. So before we start the first question, there's a few things that you need to know about vectors. First of all, is the adding of vectors, and that's very important. It is in the assignment, obviously, adding vectors. Let's just remind you, there are 2 ways to add vectors. There's the triangle rule and the parallelogram rule. Basically, in the triangle rule, if you have a vector A and you have a vector B, vector A, vector B, I should be using my pen for this, and if you have this, this would be vector C. And vector C is the sum of vectors A and B. A and B. Vector A, vector B. And if you have, this is the triangle rule of adding vectors. Triangle rule. And we have the parallelogram rule. Parallelogram rule. In the parallelogram rule, you have vector A. So let's use the same vector, for instance, A, and vector B. You don't draw the vector B from the end of the vector A, but rather from the beginning of vector A. So you draw vector B like this. Then you draw a parallelogram based on these two vectors. Basically, you complete a parallelogram, so not too accurate in here. And then you draw the diagonal of the parallelogram. And this is vector C. So this is vector A. You can see it's similar to this vector A, B, similar to this vector, and C is the diagonal. And you can see the result is the same. The result is the same vector. These are two ways of adding vectors. Because we won't be using this a lot, I just want to reiterate it with a sort of an animation. So this is vector A, the blue one, AB. Yeah. AB is vector A. BC is vector. BC is vector. Okay. And you can see that vector C is defined as C is A plus B. Okay. And if I change the vector A, you can see vector B and C change as well. So if I change vector A and vector B. So for instance, I can make vector AB go from 0 to 1, 2. So A is 1, 2. B is 2, 0. 2, 0. And the resulting vector is 3, 2. You can see, so vector A is 1, 2. Vector B is 2, 0, and vector C is 3, 2. So adding the two vectors. Let us take a screenshot of that and paste it here. Okay, so just to reiterate. So this is vector A. This is vector A. And here it is, 1, 2. 1, 2. Vector B is 2, 0. 2, 0. And C is this total of the two, is 1 plus 2 is 3. And 2 plus 0 is 2. 3, 2. Vector 3, 2. And here it is. Does that make sense? How much sense does it make on a scale of 0 to 10? So 10 makes perfect sense. Oh, GeoAlgebra, just Google it. I guess. You mean this particular one? I don't know if I know how to publish it. I guess I can. Oh, I have to sign in. I'll make sure that next time I do this, I'll use a sign in so you can share if that's even possible. Now, let's have a look at the same thing, but from the point of view of the parallelogram rule. So the triangle rule we can see. Now we just add the vectors. So you can see A1 is defined as A. A1 is the same as vector A. B1 is the same as vector B, and C1 is the same as vector C. So let's have a look what happens, and you can see that clearly these vectors make a parallelogram, and this is a diagonal of that parallelogram. So if I change the vector A and vector B, you can see that they change. So here, this is the equivalence of the two. So I'll just make it slightly more interesting like this, and I'll make a screenshot of that. No, actually, no. I'll make a screenshot like this, and you can see here. You can see here the vectors. So you have vector A, which is 1, 4 in this case. You can see vector B, which is 4, 1. Oh, that's unfortunate. Don't like symmetry in this instance. C is 5, 5. Okay, and here is C. Here is A, and here is B. Okay, so I hope that makes sense. So this is the equivalent, and we'll be using that. Okay, so going back, a pilot flies an airplane from his base to another airport 300 kilometers due north. His airplane can travel at speed of 170. He sets off at 9 a.m. Calculate the estimated time of arrival. Well, this is a PAD 2007 question, and I'm not sure what they're testing here, because I mean, it seems incredibly easy. Maybe just to confuse you with the use of AM, PM, and the time. Perhaps they're trying to catch you out, that you think that there are 100 minutes in an hour, or something. But I don't know why this question is here. It's super straightforward. It's just 300 over 170. Let's do that. So the time is distance divided by the speed, and it's 300 divided by 170. That gives you 300 divided by 170. One 1.76 hours, which is times 60 minus 60. So 1 hour 46 minutes. 1 hour 46 minutes. I hope you all know how to do this. That it's. Am I doing it? Yeah, I am. 1 hour 46 minutes. Okay, so the problem 2. After flying for 1 hour, he discovers he's only 153 kilometers from his starting point. So he's traveling at a speed of 170, but he is 153 kilometers away from where he started. and has traveled along a line of bearing 10 degrees. Assuming the wind has been steady throughout the journey, calculate the speed of the wind. So basically what has happened is that he was flying and his velocity is like this. So if there was no wind, he would end up 170 kilometers north. But because of the wind, which we don't know the direction, so he started from A, and he should have ended up at B, but actually he ended up at C, which is 153, so it's closer and it's 10 degrees, so somewhere here. And this is his true motion, 153 kilometers. And this is 10 degrees. And so the speed must have blown in this direction from B to C. And that makes perfect sense because the velocity of the plane relative to the ground is equal to velocity of the plane relative to the air plus the velocity of air. And these are vectors. And you can see the triangle rule at action here. You can see that this is the speed of the airplane, this is the speed of the wind, and this is the speed of the ground speed, basically, from A to C. All pilots know that you have to take wind into account when you're flying, and it used to be I think we might have Alexander Lwowski, Professor Alexander Lwowski joining us. Just a second, I'll send him the link. Apologies. You have to use vector additions. You can use cosine rule here, absolutely. There's no problem of using the cosine rule here, and this is the best way to go about. Of course, you can write it in column vectors. It's just it's not optimal here, not at all. And I mean, well, yeah, let's do this. So we have using the cosine rule, we have BC squared is 170 squared plus 153 squared minus 2 multiplied by 170 times 153 times cosine 10. Sorry for the mess. So cosine rule, sine rule. And so BC squared is going to be, where's my cheat sheet, is 1079. So the speed of the wind is the square root of 1079, which is 32.9. 2.9 kilometers per hour. Okay. Now, if we look at the, you can do the same on GeoGebra. So you can say the speed of the plane, v1, is 170. Okay. Hello. Alex is here. Okay. Let's pause for a bit. This is Alex. He's head of the program. He's a professor at Oxford. So Alex, to you.
Yes, hi. Yeah, nice to meet everyone. Welcome to the program. Yeah, I'm not really sure what I should say. So yeah, this program existed for about a year. So last year we had about 100 students, and now there is hopefully we'll have 300. So there's 41 of you, but many more in Telegram, and even more have signed up. So probably there'll be enough candidates, and yet we believe that we would be able to offer a place to every deserving candidate. Now, how this works, I mean, you've read it online, but let me just tell you. Again, we compose homeworks for you. In fact, for year 12, we did already compose. We'll just recycle homeworks from the last year, but we'll change them a bit, so at least some of the problems are different. In fact, in the first homework, a lot of problems are different for the reason I'm saying I'll say a few minutes later. So every month or so, a bit less, and sometimes in 3 weeks, sometimes in every 5 weeks, you'll get a new homework, which is about 10 or 15 pages and no more than 20 problems. So you have to read what's written there. And sometimes we don't write things ourselves. We just we just include links to lectures, for example, to Khan Academy lectures or some other video lectures. But when we do, then we look at them carefully. We make sure that they're consistent with the material that we want to present to you and that they're good quality. So you should read the material, watch the videos, and then try to solve the homeworks. The first homework you have to solve on your own because this is your entrance test. So, well, not completely on your own, because there is also a webinar, and also we are there, at least online, to assist you. So if there are questions, then you're welcome to message us. We'll try to answer your questions, but mostly the first assignment you're expected to do on your own. And then if you, then we mark it, if you've done decently well, and decently well means, well, last year it meant more than 50%, and really, like, it has to be more than 50%. Ideally, you should try to solve everything. So you should not, even though the threshold for admission is 50%, but we really expect you to solve everything, or almost everything, maybe except those problems marked with stars, because, well, they are kind of, all the problems form a coherent story. If you haven't solved all the problems, so if you don't know how to solve them, then you cannot say that you've learned the material. And then there are tutorials. So if you pass, then we'll assign you a tutor. By the way, if you did not pass, then you're still welcome to attend webinars, and you're still welcome to solve the homeworks. But if you have passed, then we'll also assign you a tutor. And the tutor will meet you every week for about an hour, and they'll talk about some of the previous homework, some of the future homework. I hope more the future than the previous homework. Answer your questions, and also the tutor will mark your homework and make comments how to improve. So that's how it works. There'll be 11 assignments in year 12, I think, and 9 assignments in year 13. And then if you do well, then you pass to the next year. What else to say? Please try to submit the assignments online. And well, I realized that it's a lot of work. In fact, one thing that I'm trying to emphasize, that you should not think of it as preparation for Oxford exams or any other exams or A levels or Olympiads, whatever. Because if you want to say prepare for A levels, then there are much easier, much faster ways to do so. What we are trying to do is really not prepare you for a pilot's license exam. We try to teach you how to fly. We really try to teach you physics and mathematics the way it is, at least at college, and in a way that is sort of related to scientific work, right? So you solve problems on your own, you search for solutions. Sometimes you become desperate, sometimes you become inspired, sometimes you will discover the solution and then you're happy. So you mostly work on your own, and that's how a scientist works. A scientist is primarily on their own as well. And in this way, by this experience, hopefully you will see whether or not you want to pursue a career in science. And if you decide to, then you know what's expecting you and what's needed, right? So schools, unfortunately, school science, especially school physics, is mostly about memorizing facts. It's less about problem solving skills, and what we teach you is problem solving. What else to say? You will not see much of me. Sometimes I'll message you in Telegram, but mostly I'm engaged with preparing the homeworks, aside from general sort of supervision, preparing homeworks. So first it's either, I think the first draft is the way the homeworks are prepared is the draft, and the first draft is done by Vlad, and then sometimes we involve also an external person, so often it's a professor at Oxford or a teacher, a respectable teacher at one of the UK high schools, who then write the full assignment, and then I will heavily edit it. Usually it takes me at least a couple of days to edit the homework, and then gets to you. So it's really an elaborate piece of educational material. And well, you can blame me for all the homeworks, because the last step is that after I've edited it, Vlad goes over it and fixes the typos. So you can blame me for all the typos that Vlad has not found. Right. I don't know what else to say. Do you guys have any questions? You're welcome to turn on microphones and just shout. Nobody? Don't be shy. Okay, well, you've had your chance. Oh, how many webinars a week? I think just one, and I think there'll be one. I think there'll be one for year 12 and one for year 13 in the same week. Eventually. So this week we're just doing for year 12, but in the future there'll be one for each year, either in physics or in math. Will work be set near exams? Okay, that's a very good question. So we try not to, but I think exams are given at different times at different schools. So I think at some point what we'll do is we'll post the schedule of the homeworks, and if you are not happy with that schedule, just message your tutor or message into the Telegram group. We are happy to change the deadline. Okay, next question. What about the Quantum Club entry for 2022? Yeah, Quantum Club is more advanced sort of outreach activity. So there you, well, that's basically about studying quantum mechanics. So if you're interested in quantum mechanics, you are welcome to join Quantum Club. Be prepared that it's about as much work as COMPOS, so you need to spend at least like 5 hours a week on each of those activities. So really, like, if you are doing both Quantum Club and COMPOS, that means you have no time for anything else, unless you are like some kind of prodigy. But yeah, so please fill in the application, fill in the questionnaire online, and then there is a link, and then you'll see a link to a Telegram group, same as COMPOS. Right now we have about 18 people registered. Hopefully there'll be about 100 people. In early November, we will do an entrance test. So there'll be a proper entrance test. That means that you have to solve problems online and present it to tutors orally. but we'll discuss that. Next question: are we allowed to work with each other for the assignments? Okay, so that's also a very good question. So collaboration is neither encouraged nor blamed, nor punished. So I would say, so that's for you, right? We fully understand that it's completely possible to cheat, right? There are many ways to cheat, and if you really just want a certificate, it's easy to get. But I mean, the certificate will not really give you any advantage in anything. So I hope you do not cheat, but you can collaborate, but please do not collaborate on writing up the assignment. I would say, you're welcome to discuss, you're welcome to solve together, but when it actually comes to writing it, then you should, then you should split up, go home and write the assignment on your own. Yeah. But the general ideas, so for example, if you don't know how to solve a problem, you're welcome to ask your peer students and discuss it or brainstorm together. That's more than welcome. Yeah, so another question: how does Quantum Club differ from COMPOS? So organization is very similar, except that there are no deadlines, there are no homework, there are no rigorous homework deadlines. In the Quantum Club, some tutors do assign deadlines, some tutors do choose to assign specific deadlines, but not all of them, and I definitely don't. And you get 2 hours of tutorials rather than 1 hour. And the program, the syllabus is much more advanced. So it's really proper quantum physics. So we start with complex numbers, but again, more advanced, about somewhat more advanced complex numbers than the first assignment in year 13. And then we do like linear algebra, linear spaces, operators. So stuff that's far beyond the school program. If you're ready for it, you're more than welcome to join. Or like year group wise, grade wise. If you feel, well, look at the first homeworks. If you feel that it's the right material for you, you're welcome to join. For Quantum Club, no restriction. You have to pass the entrance test. You can look at the entrance test if so that will give you a feeling whether it's for you or not. But otherwise, there is no restriction, except that you have to be from the UK. So yes, I hope I answered that question. Anything else? Okay, if not, then I'll leave it to Vlad, and I'll see you the entire year, I hope. Good luck, everyone.
Thank you. Thank you, Alec.
Bye. Yeah, bye.
All right, and back to the question about the airplane. Right, so you should see my screen. If you do not see my screen, let me know. And if you don't, so what I've done is I've drawn out these vectors. So I've the actual speed of the plane relative to the ground, the speed of the airplane relative to the velocity of the airplane relative to the air, and if put them onto a sheet. And here we are. So what I've done is, so 0, 170, that's the speed of the airplane relative to the air, and W is 153 times sine of 10 degrees. Is just GeoGebra is in radians by default, so it's 10 degrees cosine and 153 cosine 10 degrees. And now what all I need to do is I'll call it A, which is W minus V. And here we are. And you can see that this bit, it fits perfectly here. And this is the speed of the wind. Can I, what? Yeah, well, that's pretty much it. Okay, so hope that makes sense. I will probably put that sketch here as well. By the way, you can all you can all access this whiteboard. I'll send you a link. I'll send you a link in the chat, and I'll send you a link in the group, in the Telegram group. So here we are, copy, and here. Here's the meeting. You can watch in real time what I'm doing. Okay, moving on to question 2. A rower wants to cross the river to. Oh, shouldn't have done that. No. Can view and can view. Okay, so I accidentally given permission for you to change things on the board, so please don't. Hopefully I can switch that off later on. Anyways, a rower wants to cross the river to a point opposite the riverbank directly, opposite where she wants to start. So let's draw a river. We have a river, and she starts here at point A, let's say, and she wants to cross the river at right angle. So she wants to cross the river directly. Distance to cover is 100 meters, so 100 meters. And she wants to cross it in 10 seconds. 10 seconds. The river flows uniformly at 7.5. So the river flows, let's say this way, 7.5. How fast must she row her boat and at what angle relative to the flowing water? So, well, obviously she cannot row directly. She cannot row directly. She has to row at an angle. So she'll row like this. The river will cause her to drift this way, and hopefully the final velocity is here. So what we know is that this has to be 10 meters per second, because 100 meters in 10 seconds, that's 10 meters per second. And this is 7.5. Immediately we see that this is a right angle triangle, and we can find the unknown speed. So if velocity is square root of 10 squared plus 7.5 squared. And that makes, okay, 10, so square root of 10 squared plus 7.5 squared, 12.5 meters per second. And now, at what angle, how fast must you go, at what angle relative to the flowing water? So the water is flowing that way. So we can say that, so if the water is flowing that way, we need to find this angle. And well, we can find the small angle, theta. So theta is, you can use tan, so it's arctan of 7.5 opposite divided by adjacent at 10. So arctan of 7.5 divided by 10, 36.9 degrees. 36.9 degrees. And therefore, the whole angle, so the angle 36.9 plus 90 of 120 127 degrees to the flow. Okay, so I hope that makes sense. Do ask me a question if it doesn't. So this is 127 degrees, sorry. Right, so the next question was I think it was a question from, there's an entrance exam question from a long time ago, and actually from MIPT, the university I went to as a student. So it is known that 17a minus b is equal to 17b minus a. Show that the moduli of the vector is the same. Well, let's figure it out. Let's say vector A can be written as a column vector, which is A1, A1, A2. And vector B is also a column vector, so B1, B2. Now, modulus of A is the square root of A1 squared plus B1 squared, and modulus of B is square root of B1 squared plus B2 squared. All right, now let's say we want to, we look at this. We look at this expression. Well, we'll need to figure out what that is. So 17a minus b, 17a minus b should add vectors. Oh, that doesn't work. Vec is, so in this case it's 17a1 minus b1 and 17a2 minus b2. Oh, it would be a different question, Abhishek. I mean, yeah, it would be a completely different question. I mean, A2. Oh, yes, of course. B, yeah. A1, A2 squared, and B1 is B1, B2 squared. Now we can write that, we can write 17b vector minus a vector is very similar. So 17b1 minus a1, 17b2 minus a2, and we find the modulus. So the modulus in this case, I'll try to keep it brief. There's a very similar question that you have. So 17, modulus of 17 minus b, that is 17 a1 minus b1 bracket squared. Oh no, sorry. A1 minus b1 bracket squared plus 17a. So basically what we're doing is we're squaring the left-hand side. So we're squaring this and squaring this to get rid of the square roots. So we get this 17, 17a1 minus b1, 17a2 minus b2. And that's equal to, just copy. And so here we have B1, A, B, A. And now we just expand it. Yes, the recordings will be published on the website, and they will be published on the Telegram group. Okay. So let's have a look. So we expand. So 17 squared is 289, I believe. So 289, A1 squared. Okay. Let me just give you this. I've redone this. So actually, this is these are the notes. So yes, so we expand and simplify. We get this expression, and we divide it by 288, and we get A1 squared plus A2 squared equals B1 squared plus B2 squared. And then we take the square root, and that means that modulus A is equal to modulus B. So this is just pure algebra. Once you've written it down as a column vector, yes, this will be in Google Classroom as well. This. Okay, I don't want to go much deeper into this. I think it's quite straightforward. How well do you understand everything we've done so far on a scale of 1 to 10, please? Just a quick vote. I would like to hear from all of you. Heinisch. Okay. Modulus. Okay. The modulus of a vector. Do have a look. Never done absolutes. The absolute value of a vector is the length of the vector. So if you have, let's say, a vector which is 2, 4. Sorry, 4, 2. So this is 4 and this is 2. So the vector is 4, 2. And this is vector A. So the modulus of vector A is the length, and the length can be found using the Pythagoras theorem. So it's the square root of 4 squared plus 2 squared, and that makes it 16 plus 2, so square root of 20, and that simplifies to 2 square roots of 5. Hope that makes sense. So this is the definition of the modulus of a vector. So in this case, you have vector 17a minus b. So you got 17a minus b, and the vector can be written as a column vector. And the modulus of this vector can be written as the square root of that. And the 17b minus a is the column vector, 17b1 minus a1, 17b2 minus a2. And the length of this vector can be written as the square root of that. Now, if you square both sides, that takes care of the square roots, and you're left with this expression, which is then just simplified, and you go back to this. Okay, so those who put 7s and 8s, wouldn't it be conventional to label indices in the superscript? No, because then you confuse it with the power. Label indices. What do you mean? Would it be conventional to label indices in the superscript? Components of the vectors. Well, yeah, these are the components. I'm not sure I understand the question. So A1 and A2 are the components of vector A, and B1, B2 are the components of vector B. And the modulus of a vector is the square root of A1 squared plus B or plus A2 squared. So those of you who've put 7s and 8s, do you understand it better now after I've explained the modulus? All right. Why bother getting rid of the square root and not working with surgery? Assume the square root is positive. Yeah, but why would you, like, I mean, the square root here, it's just, well, you can't really do anything about it. It's just, it's going to be very painful if you try to do it with without squaring it. So how does the modulus of a vector relate to the absolute value in maths? The absolute value as in the size. Oh, yeah, absolutely. That it makes perfect sense, because look, the absolute value by definition is, if you take, this is 0, and if you take a point on the axis, let's say 0.5, modulus, okay, sorry, not 5, but x, modulus x is the distance to 0. In this way, when you understand modulus like this, modulus 5 being equal to 5 makes perfect sense, because it is 5 away from the from 0. Modulus minus 3 is 3, because the point minus 3 is 3 away from 0. So the modulus of x can be defined. It's not the definition. It can be defined as the distance from 0. You're not squaring a column. So sorry, let me finish with the vectors. And now, if you have a vector, and a vector is drawn from 0, you get the distance from 0 to that point, and that's the length of the vector. In this case, modulus, so if this is vector A, modulus A is the distance to 0, to the origin. If that makes sense. That's why we use the modulus sign. Now, there was a question about squaring a column vector. We're not squaring a column vector. Squaring a column vector is different. we are squaring the modulus of a column vector. We are squaring the modulus of a vector, and modulus of a vector is not a column. Okay, if you want to square a column vector, you multiply the vectors. So xy and xy. You're multiplying two vectors, and in fact, it does give you x squared plus y squared. But this is scalar product. This is a bit outside of this question. So let's not confuse ourselves here. When we are squaring the modulus, and the modulus is a number, is a scalar. Okay. Number line is one-dimensional vectors, absolutely. Well done. Problem 4. V is the side of sides of the parallelogram. So a diagram is in order. Always try starting with a diagram, especially in physics. And so we have the vector V. We are not sticking to 3 minus 1. I mean, it actually doesn't really matter what we do. V. And vector W. Vector W. I'm not trying to be accurate here. I'm not drawing the vectors as they are. Why am I doing it again? W. And we need these are the sides of a parallelogram. Okay, so we need to draw a parallelogram. Okay. Find the angle between the diagonals of the parallelogram. So we need the diagonals. So let's draw them in blue. This diagonal, and we already know the parallelogram rule. We know that this vector is in fact V plus W. V plus W. This is the first diagonal. Now the other diagonal is this one. And let's see what we get here. To find this diagonal, we let's give it a name. Let's give it a name A. And from the triangle rule, so triangle rule, we can see that V plus A as vectors is W. And A is W minus V. We can see that. We just rearrange to make A the subject. So A is V minus W. Does that make sense? On a scale of 1 to 10, please, how much sense does that make? That A is W minus V. Oh, that's brilliant. Okay, but okay, you understand this. That's good to know. That's good to know. A is VW minus V. Right. Now to find the angle between the diagonals of a parallelogram rule, we use the formula, the cosine. So this is the angle theta. Cosine of the angle between two vectors is the scalar product of these two vectors. So let's just do it for any vectors. Let's say you have a vector A and vector B. A and vector B. And this is the angle between them. We know that the dot product, the scalar product, A times B, is modulus of A multiplied by modulus of B. This is the definition of scalar product, cosine theta. So to find cosine theta, you need to do A multiplied by B. divided by modulus A modulus B. And we apply this. So we are trying to find the angle between these two vectors, between this vector and this vector. So we find V plus W multiplied by W minus V. Oh, sorry. Why am I doing this? No. Let's call this vector A and this is vector B. So let's find them. Vector A is W minus V. And we know that W is 1, 3, V is 3 minus 1. So this is minus 2, 4. Minus 2, 4. W minus V. And B is V plus W. So it is V plus W. So it's 3 plus 1, 4, 2. It's 4, 2. So to find the cosine between two vectors, we multiply them. So A multiplied by B divided by modulus of A multiplied by modulus of B. Okay, multiplying two vectors. So we use it's the scalar product. So minus 2 times 4 is minus 8 plus 4 times 2 plus 8. Now we'll pretend we're not noticing that this is 0. And we'll calculate modulus of A. Modulus of A is 2 squared plus 4 squared. So that's 4 plus 16. That's square root of 20. And B is in fact also square root of 20. But this is 0, obviously, because minus 8 plus 8 is 0. 0 divided by anything is 0. And theta is arc cos of 0. And it is equal to 90 degrees. 90 degrees. So you get a very similar problem in your assignment, basically almost identical. Okay, and this brings to an interesting conclusion. If the angle between vectors is 90 degrees, the dot product is 0. This is a very important result. Just remember it. Okay, we've got 5, we've got 6, we've got 7, we've got 8. We have nothing like question 6, so we might as well just skip question 6 because we only have 25 minutes left. It doesn't matter if you get the correct answer with a different method, as long as you can explain it. Okay, let's look at the notation. So here, problem 5, we have vector A and vector B. Well, we know that vector I is 1, 0, and vector J is 0, 1. So these are the base vectors. And if you draw a 8 from the assignment, or 8 from the 8 from my list. So this is vector I, and this is vector J. So of course, vector A can be written as, so question, yeah, Jed, question 8 from my list or question 8 from the assignment? Please let me know. A is 4i minus 3, so it's 4 minus 3. B is -2,5. -2,5. So we've written them as column vectors. AY is actually the projection of A onto the y-axis. So it's the y component. So if you have vector A, 4, -3, yeah, let's do it here. So A, oh, A is 4, -3, and draw this vector. I is 1, 0, and j is 0, 1. These are base vectors. It's definition. The coordinates of the unit vectors. It's their definition. So this is vector A, which is 4, 3. 4, 3. Now, what I'm going to do is draw a vector which is the projection of A. Sorry, of A. You need AY, isn't it? AY. So AY is the projection of vector A on the y-axis. So it's the shadow of vector A, if you will. It's the shadow of vector A drawn drawn on the y-axis. And here it is. This is vector AY. Algebra. Call this AY. And obviously it is 0 in the x direction and it's -3 in the y direction. So AY is 0, -3. A times J. So A, so 4 -3 multiplied by J, and J is 0, 1. 0, 1. And we use the dot product. So 4 times 0 is 0, plus -3 times 1 is -3. And it's actually -3. And this is -3. And it's not a coincidence. The dot product of A and the J vector is the y component. If you do A times I, you will get 4, because that gives you, multiplying the vector by the base vector gives you the component, gives you the coordinate. AY is just the length, so it's AY is the, well, it depends on how you look at it. Sorry, AY is the component, so it's -3. Yeah, it's the component of the vector without the vector. A times B is the dot product between A and B. So 4 times, so AY is the component in this case, not the modulus. A times B is 4 times -2 is -8, -8, -3 times 5, -15. And that gives you -23. This, well, you need to expand that. So 2A times A, it's 2A times A, minus 2A times 3B, so it's 6A times B. B, no, because this is a scalar product, and the answer is a scalar, is not a vector. that is important. This is important to understand. 6AB plus BA. You know, sometimes you are allowed to drop them vector signs, the vector symbols, if it's quite obvious what you're doing. Minus 3BB. And AA, so it's vector A times A. So it's 4 times 4, 16. 16 times. You know what? I'll leave it to you to complete it. I'll do it in a different way. Rather than calculating all of these, I'm going to find 2A plus B. 2A plus B. 2A plus B is 2A, it's 8 minus 2, so it's 6. Minus 6 plus 5 minus 1. And then A minus 3B. So A minus 3B, so 4 plus 6 is 10. Minus 3 minus 15 is minus 18. If I made a mistake, correct me. But otherwise, and when you multiply them together, it's 6 minus 1 multiplied by 10 minus 18. 6 times 10 is 60. Minus 1 minus 18 is plus 18, so it's 78. Okay, I really want to get to question 8 because it's amazing. It really is. Problem 7. A small airplane's airspeed at landing is 60 knots. This is these are real numbers. So if you ever flown or will fly in a small airplane, you usually come into landing at 60 knots, which is about 70, 80 miles per hour. There's a steady crosswind. Crosswind is a side wind of 10 knots. How should the pilot direct the aircraft in order to remain flying in a straight path? What is the plane's ground speed? So to understand this, well, it's really nice to watch. It's really nice to see videos. I love videos of crosswind landings. Crosswind landings. Oh, this one looks nice. So here you can see an airplane. This is an A340 landing at Düsseldorf Airport, and this is a view along the runway. As you can see, it seems that the plane is going sideways because there's a strong wind from left to right. The airplane has to steer into the wind. Okay, so let's get back to our A340. Amazing aircraft. Sorry, I like planes. And so here we are. Okay. So we're going to look at this from the view from the top. So we can see so this is the runway. And the plane, let's say the pilot flies this way. at 60 knots. Okay, 60 knots. And there's a crosswind. So the crosswind is like this, of 10 knots. This would result in the plane flying like this, which is not good. Okay, if you ask any pilot, that's not the way to go. So this is not good. What you want is you want the plane to actually travel like this. But because there's wind, so you have to steer the plane into the wind. So you steer the plane like this, and then the wind will blow you off course, and as a result, you would travel in a straight line. Okay, is that making sense? On a scale of 1 to 10, please. So this is wind. This is we call it air speed, air velocity. And here this is we call ground velocity. Ground velocity. So look, in most questions involving vectors, just a good diagram is half the job. And so this is 60. This is the speed of the plane. This is relative to this is 10 knots. And then you can use the magic Pythagoras theorem to find the ground velocity and the angle. Okay, so the angle is arc sine in this case. Arc sine. Arc sine is the same as sine minus 1. Yeah, if you were wondering, sine minus 1 and arc sine are the same thing. It's just my personal preference, and probably in most universities you would see arc sine used more often than inverse sine. Arc sine of 10 over 60, which is roughly, should be about 0. Well, I won't embarrass myself trying to guess the angle. So it's 1/6, 9.6 degrees. 9.6 degrees, and the actual ground speed, velocity ground, is using the Pythagoras theorem is 60 squared minus 10 squared, which is 50 something. So square root of 60 squared minus 10 squared. Oh, interesting. It's 59. 59. 0.2 knots. Okay. That's it. Any questions? Any questions? We have 10 minutes left, and I want to go through the most exciting problem, the most difficult problem of the assignment. So if you've seen this, and at first it seems like it's the same question as with the plane. A boat is crossing a fast river. The speed of the boat is 2 kilometers per hour. The speed of the river is 7. How should the driver direct the boat in order to keep up as close to the starting point as possible? So let's say you have the riverbank, You start from point A. You want to cross the river. You want to end up as close to point B as possible. And we know that the speed of the river is 7. Okay. So the speed of the river is 7. Why not just go like this? And then this would be your actual speed. So this is 7 kilometers per hour. So why is this not possible? Somebody tell me. So this is the speed of the boat relative to the water. This is the speed of the boat relative to the shore. And this is the speed of the water. Yeah, the hypotenuse would be 2. Brilliant, absolutely. The hypotenuse would be 2, which is not possible because the opposite side is 7. So it is not possible. If the river is faster than the boat, it is not possible to cross at a right angle. So your aim is to minimize that angle. You want to minimize that displacement. So perhaps you could cross it like this, and perhaps you want to cross it. You can cross it like this. You want to end up as close to this as possible. And we will use my new friend, GeoGebra. So it was just today preparing for this webinar. I have learned lots of new tricks. Actually, I'm quite proud of myself. So let's say you have a line. So I'll just draw a line. So this is the shore, and this is the other shore. Okay. Just make it more greener and thicker. Thicker and greener. Okay, and go to algebra. We're not interested in those points. Let's say we start at point. Here, E. And the boat can travel in any direction. Okay. Well, some of the direction won't be reasonable, but in fact, if you draw that, it's 2 kilometers per hour. 2 kilometers. It can travel in any direction whatsoever. So let's draw a vector. Let's say it could go like this, for example. Or no, I don't want that. Can draw a vector like this. Can I? No, just allow me to move. Can I move it? Oh, yes, brilliant. I can draw this. Okay. And this is the speed of the boat. So in any direction, I can direct it this way. Won't be very useful. I can direct it this way, this way, this way, this way. Okay. Now I'm going to draw the speed of the river. So let's call it R. And this is going to be is plus 7, 0. Okay. And oh, and oh, so sorry, the river is no, this should be R. This should be R, and R is the vector G R. No, not helping. Oh, vector, of course. Forgot the word vector. Yes, here we go. So U is the speed of the boat, and R is the speed of the river. And now you can see I can rotate U, and that changes which way the boat is going. And finally, I can put a vector, so velocity of the relative to the shore is a vector to ER. ER. And we want to show that, and we want it to be marvelous. Okay. Now we can change the way the boat is going. We add this to the flow of the river, and we can see where the boat will end up. So one more thing is we can add a ray. Let's see. And yes. So like this, the boat will end up somewhere here. And you can see this is the maximum. So it can end up here. If you keep increasing the angle, it will end up here. You need to end up further away. And so there's a sweet spot. There's a sweet spot somewhere here. Okay. And Yes, sorry. I was just so this is the speed of the boat relative to the water. This is the speed of the river. This is the total speed, the speed of the boat relative to the shore. And somewhere here we get a sweet spot which minimizes the displacement. And sorry, I'm just trying to make sense of it. Why is it like this? Oh yeah, so we're trying to minimize this angle, and you know what? We can actually play around with it a little. You can find this angle, this one. So it's 16 degrees, 16.4 degrees, and 16.4, 16.5, 16.6, 16.6, 16.6 seems like this is the maximum. And how to determine that this is the maximum? So we can screenshot that and just look at it from a slightly different perspective. So as long as you understand the mechanics, what's going on here, the rest is just another diagram, and hopefully you'll understand how to determine this angle. So you want to minimize this angle. Sorry, maximize this angle. Sorry, of course, as to minimize the drift, the displacement. So let's look at the same thing from a different perspective. So the speed of the river goes sideways, and it's 7. So this is the speed. This is the speed of the river. Then we have the speed of the boat relative to the water, and it can be anything in this circle. The boat can travel in any direction on this circle, like this, etc. Now, let's say the choice is like this, and that means that the final velocity is like this. Now, when will the optimal be achieved? When will the optimum be achieved? Optimum. Well, when this point, anyone? Can anyone see it? When will this angle be maximized? Absolutely. When this is the tangent. Yes, we are interested in this scenario. When the boat goes like this, and the final velocity is like this. Any other position, it would be less. So theta is maximum, is max, when this is a tangent, when this is at the top. So this is the velocity of the boat relative to the shore. And this is the velocity of the boat relative to the river, when VB shore is tangent to the circle. Now, this is the last problem and the hardest one. Please be very careful when you describe, when you're explaining it, because what we will be looking at is that you actually understand what's going on, not because this is pretty much the whole solution. The numbers are slightly different, but yeah, and the angle. So obviously this is 2, and this is 7. So you have the arc sine 2/7. I'll leave you with the details, but this is the idea. And do experiment with GeoGebra. It's really good fun. It does take some time to adjust. How can you show that it's optimal without calculus? Well, because from the diagram, you need to maximize this angle, theta. And the 7 is fixed. The base of the triangle is fixed. This point can be moved along the circle. And the question is, in which position of this point, let's call it point X, point this O, and this is point A, the point X can move around the circle. In which position will this angle be maximum? And you can see that if you move X to the right, this angle decreases, and if you move X to the left, this angle also decreases. Yes, I mean, basically shorting the graph. That would be difficult because you're providing written solutions. Yeah, VB shore is what we are looking for. VB shore and the angle. We need the angle and the VB shore. The question is, what angle should the driver direct the boat? The boat's going. How should the driver direct the boat in order to end up as close to the starting point as possible? So, yeah. It is arc sine 2/7. Yeah, it is arc sine 2/7. Can we submit digitally written notes? I don't see a problem with that, as long as it's clear that it's your work. Just make sure it's a PDF. I mean, if you this is I drew. This is it's a really cool thing, but and you can download a PDF once you've done. The only thing is to add pictures, you have to have a paid version. So maybe I know Apple Pages does that, but please submit your work in PDF format. Otherwise, it just gets really messy. So is the origin of the circle B the other side of the shore? No, O is the starting point in this scenario. In this scenario, O is the starting point, and X is the chosen direction. So OX is the chosen direction. Oh, sorry. Yeah. The angle we're looking for, sorry, is this one, alpha. This is so alpha is the chosen direction. All right. So this was the first webinar. Next week we are going to do maths. I do have to run. We've went over time. We will have guest lecturers for our webinars, for some of the maths assignments. So what we'll do, we'll have we'll have, you typically have 3 weeks to prepare the homework. The assignment is due 16th of October. So you get a month, over a month left. You got 40 days to do the assignment. So you got plenty of time. This is because we're still recruiting. We're still recruiting tutors, which will be teaching you in the future if you're successful with the assignment. But you are always welcome to attend webinars, even if you don't get through, if you don't pass the entrance test, you're still welcome to attend the webinars. You're welcome to communicate with us. You're welcome to access the assignments. Like question 8. Well, it's you can't really go closer to the actual question. Yeah, please mind that they're asking of how you should direct the boat, and so theta is how the boat would actually go, and alpha is your chosen direction. Yes. So okay. So see you all next week. Hope to see more of you next week, and good luck. You're welcome. Welcome. See you.
Thank you, sir.
Welcome.
Thank you.